How can we identify risk factors on roadways before crashes occur? While reviewing crash data can help agencies get a sense of patterns, we don't want to wait for serious injury or fatal crashes to take place before taking action. Fortunately, agencies have tools at their disposal to help them proactively identify potential conflicts between vehicles, pedestrians, and bicyclists. One approach for this is video-based conflict monitoring. Conflict monitoring means identifying situations and the corresponding circumstances that produce near misses. A near miss is when two users almost crash. In this video, we'll break down the fundamentals of video-based conflict monitoring and define common conflict monitoring measures. But first, we need to understand surrogates. A surrogate safety measure is an indirect way of measuring roadway safety performance. While not a one-to-one replacement for measuring crashes, surrogate measures can help us assess safety performance through measuring things that correlate to crashes. Surrogate safety measures include potential conflicts between users, collision avoidance behaviors like evasive actions or excessive deceleration, and road user behaviors like traffic violations, lane encroachments, or delayed reaction time. The degree to which a surrogate measure provides a reliable indication of safety performance can vary from measure to measure. The stronger the correlation between the surrogate measure and crash frequency or severity, the more reliable of a measure it is. So, how can we use conflicts as a surrogate for crashes instead of waiting for crashes to occur? Conflict monitoring is built on the understanding that higher concentrations of conflicts indicate a greater likelihood of crashes if left unresolved. As the name suggests, video-based conflict monitoring uses cameras to record road user interactions at intersections and software to flag potential conflicts or near misses within the footage. So how are conflicts measured? Here are a few of the surrogate safety measures commonly used. Time to collision, or TTC, predicts the time remaining before a crash would occur if the paths and speeds of two road users are maintained. A smaller value indicates a higher likelihood of a collision. This measure can be used for all road users. Post-encroachment time, or PET, measures the lapsed time from when a road user leaves a specific location or conflict point to when another user arrives at that location. A smaller value indicates a higher likelihood of a collision. While it can be used for all road users, PET has some limitations, which we'll discuss later on. Delta V represents the change in vehicle velocity in the event of a collision. This measure is used with other surrogates to add supplemental information about crash severity. A larger value indicates a more severe crash. Modified time to collision, or MTTC, predicts the time to collision that includes consideration of the likely deceleration of the involved road users. A smaller value indicates a higher likelihood of a collision. MTTC is typically used to evaluate rear-end conflicts. Deceleration rate to avoid a crash, or DRAC, is the minimum required deceleration rate a vehicle has to apply to avoid a crash. A larger value indicates a higher likelihood of a collision. When using any surrogate safety measure, you'll still need to do some post-processing to get the most accurate results. Human review and judgment is required to verify the data that software can pull from video monitoring depicts true conflicts. For example, some encounters, like a pedestrian waiting for a car to pass and then crossing the street, or a permissive left turn made after a through vehicle passes by, could be a legal, safe interaction. Human judgment must always be part of the equation. On top of that, it's important to be consistent when picking a conflict monitoring measure, as well as a vendor who can provide the video-based conflict monitoring service. Different vendors may have different definitions of the measures. For example, one may measure PET using the edge of the vehicle, while another measures it using the center, which makes a difference when you're comparing milliseconds. Since industry conflict measures aren't standardized, picking one vendor and sticking to their definition consistently makes your before and after data reliable. Not all vendors offer the same performance measures, so be sure to understand what they offer and whether it will meet your needs. This is a rapidly evolving topic, and we welcome further questions, observations, and success stories. Subscribe to our newsletter in the description below for more timely transportation news.